Alright, in this lesson we will learn to solve and graph quadratic inequalities like this. Alright, the first thing we need to do is we need to find the zeros of this function, the x-intercepts. Understand, this is a quadratic equation. We see that it's degree 2, so that means it's going to be some type of a parabola. Alright? Now, because this is some kind of a parabola, typically what's going to happen is it's going to cross the x-axis at 2 points, like here and here. And so when we're dealing with an inequality, so this symbol means less than. Alright, so if the parabola were looking like this, then we'd be looking for from where to where is the graph below the x-axis, okay, because the x-axis is at 0. So if it's less than, we're looking for below. So we need to know what these values are. For example, you know, if let's say if my y-axis was here, okay, and maybe this is -1 and this is 3, then we'd say, okay, the graph is less than 0 between -1 and 3. Okay, and I guess really we should do open circles. I erased my whole graph. We should do open circles because it's less than, not less than or equal to. And so we'd say, oh look, it's between -1 and 3. So we do like this, and that would be the answer. Okay, that's just a quick example, but right now we don't know what the x-intercepts of this graph are. So what we need to do is factor this and set it equal to 0. So let's go ahead and factor this and set it equal to 0, and that will let us find the x-intercepts. So looking at this 4x squared first, 4x squared is probably going to factor as 2x and 2x. But if this doesn't work, we can always go back and try 4x and x. So do this in pencil. Now the 3 is going to factor only as 3 and 1. That's the only way. So let's try this, 3 and 1. Now the inner plus the outer has to equal the middle. So when I say inner, I'm talking about these. When I say outer, I'm talking about these. Okay? So inner, I have 6x. Outer, I have 2x. I'm trying to get a middle of -8. Is there a way that I can get -8 out of 6x and 2x if I choose the signs properly? Well, yes, if I have a -6 and a -2, that will give me -8. So I can get a -6 if this is negative and a -2 if this is negative. Alright, we need to check one last thing. Are we getting the +3 that we need? Well, yes, -3 times -1 is +3. So this is now factored properly. Alright, I'm just going to erase that, get it out of the way. So now that it's factored properly, let's set these factors equal to 0, and that will tell us the x-intercepts. Okay, the zeros of the function, if you will. So let's set these equal to 0. So 2x minus 3 equals 0, and 2x minus 1 equals 0. Adding 3 to both sides, that gives me 2x equals 3, and then I'd have to divide both sides by 2. So that'll give me x equals 3 over 2. Okay, so that's one of my x-intercepts. Alright, by the way, this is, 1.5. And meanwhile over here I'd add 1 to both sides, so that's going to give me 2x equals 1, and then I would divide both sides by 2. So that's going to give me x equals 1/2. Okay, so these are our x-intercepts. So let's go ahead and include that on the graph. So we have 1.5 and 1/2. Okay, so 0.5 is going to be, 1.5 is going to be right here. You know what, I don't like this. Those numbers were too close together, so I think I'll just give you a number line and let you put your own numbers on it so we can spread these things out a little bit. Always include 0 on your number line just as a frame of reference, so 0 is over here, for example. Okay, now like I said, we have 1/2 and we have 1.5, so basically 0.5 and 1.5. So 1/2 is going to be, let's just put it like right here. Okay, that's 1/2. And then 1.5, let's just spread it out. Let's put it over here somewhere. Okay, so this is 3/2, which, think 1.5. Okay, and this is 0.5. Okay, we really don't need all of those other numbers on the number line to do this problem. So let's just spread it out, give ourselves some room, and just do it like this. Okay? Now, let's plot these as points. So we're either going to do open circles or we are going to do closed circles. So looking at this inequality symbol, am I going to plot these points as open circles or closed circles? These are going to be open circles, okay? And most people put their graph right on the line. I prefer to put my points sort of floating above the line. So you do it how your teacher does it. Okay? But if you're in Mr. Burton's class, please float your graph above the line so I can see it. So we'll use open circles because this is less than. If this had been less than or equal to, like that, then we would have used closed circles to show that the endpoints themselves are included. Alright, but we need to be less than 0, so we won't include the endpoints. Okay? Now, with these endpoints, with these x-intercepts, we have now divided the graph into 3 zones. Let me show you what I'm talking about. Okay, so let me put a line right here, and we'll put another line right here. So look, we have divided this graph into 3 zones. We have a zone on the left, okay, we have a zone in the middle, and then we have a zone on the right. Okay, we have now divided the graph into 3 zones. And what we need to do is we need to pick a test value, an x value from each one of these zones to try out and see if it makes a true statement when we plug it back in to the inequality. Okay? So, in the yellow zone, let's decide what value we're going to pick. Let me go ahead and do like this. Alright, in the yellow zone, let's use 0. 0 is always an easy value to use. So if 0 is in the zone, go ahead and use that. So we'll use x equals 0 for our test value here. What's a value between 0.5 and 1.5? Okay, how about 1? Okay, yeah, 1 is between 0.5 and 1.5. So let's just use an x value of 1 would be a good one to use. Now, in this zone, by the way, we didn't have to pick 0. I could have picked -1 or -2 or -3, and this goes forever. Anything less than 1/2 I could have picked. Okay? Now here I could pick any number higher than 1.5. But I think I'll just do x equals 2. Alright, it's just the first number, the first integer that's greater than 1.5. I'm just going to pick that. Okay, so now I've picked a test value in each one of these 3 zones. So what I need to do is I need to plug them in, substitute them into the inequality. Now if I were you, I would use the factored form. So remember, we set this equal to 0 so we could find the x-intercepts, the zeros of the function. But really it's not an equality, it is an inequality. It's less than 0. So let's go back to that. So this is what we will be substituting into. So we'll be doing 2x minus 3, 2x minus 1 is less than 0. Okay, let me just go ahead and put that down. So 2x minus 3, 2x minus 1 is less than 0. And one more time, 2x minus 3 times 2x minus 1 is less than 0. Alright, let me zoom in more. Okay, my first test value is 0. So I'm going to substitute in 0 for these x's. Okay, so that's going to give me, okay, and you know, let me just set this up real quick because I want to change colors if I may. Alright, because I'm substituting in 0. So I'm doing 2 times 0 minus 3 and 2 times 0 minus 1. Okay, I just want to emphasize that. Alright, and we're trying to see, is this a true statement? Alright, is x equals 0 a solution to this inequality? So let's go ahead and evaluate. So 2 times 0, of course, is 0. So I have 0 minus 3, and then 2 times 0 is 0. So I have 0 minus 1. Okay, now 0 minus 3 is just -3. 0 minus 1 is just -1. Okay, a negative times negative is positive, so this is going to give me +3 is less than 0. Okay, now is this a true statement or a false statement? Alright, is this a yes or no? Okay, is 3 less than 0? No, 3 is not less than 0. Okay, so this is not a solution to the inequality. So that means if one value in this zone is not a solution, that means none of the values in this zone will be a solution. So I'm really just going to erase this, and I'm just going to leave it empty. Nothing is going to happen here because these values are not solutions. So let's move on to our next zone. Okay, so let's use our test value of 1. So let's see. So I've got, let me just set it up. Okay, so now I'm doing a test value of 1. Okay. So 2 times 1 is 2, so 2 minus 3 and 2 minus 1 is less than 0. So this would get 2 minus 3 is -1, so this gives me -1 and +1. okay, is less than 0. And then negative times a positive is a negative. So this would make negative 1 is less than 0. Okay? Is negative 1 less than 0? Well, yes. Yes, it is less than 0. Okay? All of the negative numbers it'd be over here, you know. Negative numbers are all less than 0. So that means 1 is a solution to the inequality. That means all of the values in this zone will be solutions to the inequality. So because these are solutions, we will go ahead and show that by filling in this part, this segment between the two endpoints. Okay? That's showing that these are all solutions to the inequality. Okay, now let's do our third and final test case of x equals 2. So let me just set it up one more time. Okay, so test case of 2. So I'll make this 2 times 2. And let's go ahead and see what happens. So this is 4 minus 3 and 4 minus 1. Okay, 4 minus 3 is 1 and 4 minus 1 is 3. 1 times 3 is 3. And then we ask ourselves, is 3 less than 0? No, 3 is not less than 0. So that means x equals 2 is not a solution to the inequality. That means none of the values in this pink zone will be solutions. So we will just leave this empty. So that means this little segment represents all of the solutions to the inequality. Alright, so we have the graph, but we need to use this graph to write an interval representing these solutions. Okay, so our solution set is from 1/2 to 3/2. So we'll write it the same way we would a domain. So we will say the solutions are from 1/2 to 3/2. Okay, and go ahead and just stick with the fractions. Now, am I going to use round parentheses or square brackets to close this off? I'm going to use round parentheses for the same reason that we have open circles. Okay, we wanted to know where the graph is going to be less than 0. The endpoints represent where the graph is equal to 0, not less than. So we don't want to include the endpoints. So we will use round parentheses to show endpoints are not included. So this is the solution. Okay, this is not an ordered pair. This is not like an x value and a y value. This means the interval from 1/2 to 3/2, not including the endpoints. So this is the solution, and this is the graph of the solution. And that, my friends, is how you solve and graph a quadratic inequality. Now let me connect this back to parabolas. We're done. Okay, that's the answer. I just want to make one more little connection with you though, if I can. Please understand what's happening though is this is a parabola. Okay, in fact you should know, is this an upward facing parabola like this, or is it a downward facing parabola like this? Yeah, it's an upward facing parabola, and you know that because it's a positive leading coefficient. Okay, so here's what's really happening with this problem. Let's see, what color shall I use? I'll use green. So this is a parabola, and it's upward facing, so what's really happening is something like this. Okay, so we have this parabola, and we're being asked, where is the parabola less than 0? Okay, less than 0 means below the x-axis. So we're being asked, where is it less than 0? Well, it's going to be less than 0 below the x-axis. So that's why the solutions are between 1/2 and 3/2, because this is where the parabola would be below, okay, less than 0, below the x-axis, would be between the x-intercepts in this case. Okay, so that's just the big picture for my visual learners. If that didn't make sense to you, then just stick to your test values. I mean, we have to do the test values either way. You got to show your work and all that, but I just wanted to make those connections if you could try to understand. Alright, I can't believe I filled up the entire video with one problem. I'm hoping I can do the next example faster, but I am going to end this video right now. If you need more practice, more help from me, see me on the next video. We'll do another one of these problems together.